Let's explore how our bodies handle sugars, how insulin is produced and works, and how to prevent, manage, and even reverse diabetes. Stick around for a surprising fact midway through the video. Let's start with what happens to sugar in our bodies. When we eat sugars like glucose, fructose, and sucrose or carbohydrates, the journey starts in the mouth. Here, an enzyme in saliva called amylase begins breaking down starches into simpler sugars. This process continues in the stomach and small intestine, where enzymes like pancreatic amylase, maltase, sucrase, and lactase break down carbs into monosaccharides, the simplest sugars. These are then absorbed into the bloodstream. As glucose enters the bloodstream, blood sugar levels rise, signaling the pancreas to release insulin. But how does this work? Insulin is made in the beta cells of the pancreas. When blood sugar levels go up, glucose sensors in the pancreas detect this and trigger a series of reactions. Glucose transporters, or GLUT2, help glucose enter the beta cells. Glucokinase phosphorylates glucose, which is crucial for its metabolism. ATP, produced from glucose, helps close potassium channels in beta cells. Closed potassium channels cause cell depolarization, opening calcium channels and releasing insulin. Insulin then travels through the bloodstream to muscles, organs, tissue, and fat cells, helping them take in glucose. Insulin binds to receptors on cells, activating insulin receptor substrate, or IRS, and causing GLUT4 transporters to move to the cell membrane. GLUT4 lets glucose into the cell, where it's used for energy or stored as glycogen. Certain vitamins and minerals are vital for these processes, such as chromium, which enhances insulin action. Magnesium, essential for glucose metabolism. Vitamin D, which affects insulin sensitivity and secretion. And zinc, needed for insulin storage and release. Lack of these nutrients can impair glucose metabolism and insulin function, leading to diabetes. What's the role of the gut and gut flora? The gut microbiome, made up of trillions of microorganisms, plays a big role in health, including glucose metabolism and insulin sensitivity. Good bacteria like Bifidobacterium and Lactobacillus help by producing short-chain fatty acids, or SCFAs, that reduce inflammation and improve insulin signaling. Candida, a type of yeast, is usually present in the gut in small amounts, but when it grows too much, it can cause problems. What role does Candida play? Here's where it gets interesting. Candida overgrowth can disrupt the gut microbiome balance, leading to inflammation, immune issues, and insulin resistance. Inflammation from Candida can damage the gut lining, causing leaky gut, which lets toxins, microbes, and partially digested food particles, and yes, Candida into the bloodstream, leading to systemic infections, and contribute to various health issues such as inflammation and autoimmune diseases, worsening inflammation and insulin resistance. What does sugar have to do with Candida? High sugar intake feeds Candida, promoting its growth. This creates a cycle of sugar cravings, which, by the way, are partially created by chemicals released by Candida and further Candida overgrowth. Managing sugar intake is crucial to maintain a healthy gut and prevent Candida overgrowth. To keep your gut healthy, eat a balanced diet with fiber, fermented foods, and probiotics. Fiber feeds good bacteria, while fermented foods add beneficial bacteria to the gut. Probiotics can balance the gut microbiome, reduce inflammation, and improve insulin sensitivity. In summary, a healthy gut microbiome, including a balance between good bacteria and organisms like Candida, is crucial for glucose metabolism and insulin sensitivity. Managing sugar intake and promoting gut health can help prevent and manage diabetes. Insulin resistance is key in type 2 diabetes. It occurs when cells become less responsive to insulin. Let's explore what causes insulin resistance. Normally, after eating, blood glucose levels rise, prompting the pancreas to release insulin. Insulin helps cells take in glucose. In insulin resistance, this process is impaired due to chronic inflammation. Often caused by obesity or stress, inflammation can interfere with insulin signaling. Oxidative stress. Free radicals can damage cells and impair insulin signaling, often due to obesity or high blood sugar. Hormonal imbalances. Stress hormones like cortisol can counteract insulin. Nutrient deficiencies. Magnesium and vitamin D are essential for insulin function. Deficiencies can lead to insulin resistance. Gut health. A healthy gut microbiome reduces inflammation and supports insulin sensitivity. In insulin resistance, the insulin signaling pathway is disrupted. Insulin receptor dysfunction. Insulin receptors can't transmit signals properly. Post-receptor defects. Signaling proteins like IRS and PI3K may be dysfunctional. GLUT4. Translocation. Impaired GLUT4. Translocation reduces glucose uptake. Lifestyle factors like poor diet, inactivity, and stress can worsen insulin resistance. Exercise, a balanced diet, and stress management can improve it. To prevent, manage, and even reverse diabetes. Diet. Eat whole foods, including fruits, vegetables, whole grains, lean proteins, and healthy fats. Avoid refined sugars and processed foods. Exercise. Regular physical activity improves insulin sensitivity. Stress management. Techniques like mindfulness and yoga help reduce stress. Adequate sleep. 7 to 9 hours of quality sleep supports health and glucose metabolism. Regular monitoring. Keep track of blood glucose levels. Supplementation. Vitamins and minerals like chromium, magnesium, and vitamin D support glucose metabolism. These lifestyle changes can sometimes reverse diabetes, especially if started early. Work with healthcare professionals to create a personalized plan. Don't just settle for treating the symptoms. Get to the root of the problem. If not, the problem will only worsen. Thanks for joining us on this journey through sugars, diabetes, and insulin resistance. By understanding how our bodies handle sugars and the role of nutrients, we can take steps to manage and prevent this condition. Remember to like, comment, and subscribe for more health information. Until next time, take care of your health. And remember, there's a healthier way to better health.